Welcome back to the Monash Chemistry Labs to perform our second experiment for 1011. In today's experiment, we're going to be looking at some chemical reactions of different copper compounds. More to the point, it's going to be another experience practicing some of your chemical techniques and using different instruments and different kinds of reagents for chemical experiments. Once again, you're going to be using our analytical balances, but on this occasion you're going to be using some slightly more hazardous materials such as concentrated acids and bases. The aim of today's experiment is to perform a few chemical transformations to eventually get from some copper chloride to metallic copper. You'll get the opportunity to perfect some of the skills at handling glassware and careful use of concentrated acids and bases. It cannot be stressed enough how important it is to ensure that you're wearing your lab coat and safety glasses at all times during today's experiment. If you've finished, but others around you are still performing the experiment, please continue to wear your safety gear. Once again today you'll be using the analytical balance, and it's very important to make sure that you've weighed out your copper chloride to 4 decimal places. And this means weighing your filled watch glass before and after. Use a measuring cylinder to add 10 mils to your copper chloride. I know many of you will be pleased to see that we don't have to use the 10 mil pipettes and the pipette fillers for this exercise. Once you've added the deionized water, swirl to dissolve your solid. The next step is going to be the actual chemical reaction taking place. We're going to use 4 molar sodium hydroxide solution, and we'll add 1 ml of this dropwise to the solution. This should hopefully form our copper hydroxide. Once you've added the sodium hydroxide, swirl your solution to ensure that the reaction is complete. There's a test that we can do to verify that the reaction is complete. Once you've swirled with a glass rod, you can take the tip of that glass rod and touch it on a small square of litmus paper. For the reaction to be complete, there should be excess sodium hydroxide, and if there's excess hydroxide, you should see a colour change on the litmus paper. Here you can see it's a blue, which indicates it's complete. To convert your copper hydroxide to copper oxide, you need to heat this blue solution. Use a peg to mount your beaker on the steam bath. You'll be looking for a colour change from this nice sky blue to a dark black colour. Swirl regularly to ensure that the reaction has gone to completion, and when you're satisfied, use the peg to lower the beaker. To complete the next step of the experiment, you need to filter your copper oxide. This is a simple filtration, and we'll just use a piece of circular filter paper which is folded in the following manner before putting it into a small funnel. You can see in this case it's been folded so that it has 8 folds and is then placed into the funnel. A small amount of water can be used just to help the paper stick to the sides of the funnel. Once you've mounted your filter paper, take the beaker of copper oxide and slowly pour into the funnel. You might not be able to pour all of it in at once, and this may be stepwise. There will be some waiting here, and it's a good chance to start filling in some of the details on your proforma. Once you're satisfied with your copper oxide collection, it's time to move on to the next step. Use a metal spatula to make a small hole in the bottom of the filter paper. The aim in this next step is to use 4 molar sulfuric acid to push the copper oxide through that small hole at the bottom of the filter paper. Using the dropper from the acid bottle, rinse the spatula down so that any copper oxide moves through the small hole. Try and push as much of the material through as you possibly can. You should start seeing in your collection that the solution has taken on a bit of a blue colour. This, of course, is copper sulfate, which is starting to form in a solution. It's also okay to try and push as much of this material through using distilled water. Take a distilled water bottle and just start rinsing the filter paper through. Even if the copper oxide hasn't reacted at the top level, it will fall down into the sulfuric acid and react to give copper sulfate. During this step of the experiment, take out your zinc powder, which you've collected on a watch glass, and slowly add to the copper sulfate solution. You should see a reaction taking place and hopefully lots of fizzing, which is the evolution of hydrogen gas. Your copper sulfate will be getting converted into copper and zinc sulfate in solution. To complete the experiment, we now need to decant off the acidic material. Decant into a beaker which you've labelled acid waste. Be very gentle and try to make sure none of your solid material falls into this. You should now rinse your copper material 1 or 2 times with about 10 ml of water each time. Once again, you don't need to use a pipette filler, just use a measuring cylinder, that'll be sufficient. And do this rinse a couple of times. Once you've satisfied that you've gotten rid of most of that acidic waste, you do need to still test to see if there's any unreacted zinc. To do this, take some hydrochloric acid from the dropper bottle and add a small amount just to make sure there's no more hydrogen gas being evolved. If you're satisfied that there's no fizzing, then your experiment is finished and decant off your material again. The final step in today's experiment is to determine your yield. This is really a measure of how successful your conversion was. To calculate your yield, you simply need to divide the number of moles of copper by the moles of copper chloride dihydrate that you started with, and then multiplying, of course, by 100. Good luck in today's experiment.